I have the same. I just finished yesterday. Some lots will be probably Monday, but it's a couple of bits left, so it's not nothing major.
Yeah, we're wrapping up. We're hopefully within the next couple days. We've got to go through all our test fire. Make sure we get everything taken care of. Get ready to get back online, I guess, and then we'll go back to normal.
All right.
It's not bad.
Elliot here now. Yeah.
Hey guys, what's up?
Hello.
What's going on?
You see my display?
Yes.
Okay, awesome. Yeah, I can't tell from
I'm like-
Teams.
Hey guys, how's it going?
Good.
Another busy Saturday.
Mm-hmm. Every Saturday.
Yeah.
You work every Saturday, Steve?
No, we're in outage right now.
Right, you
So
said that.
we're getting to the end, but hopefully this is the last weekend I'm gonna be out here. So we're just talking about I've been working anywhere from 14 to 16-hour days the past 3 weeks.
Ooh.
Yeah, it's been I'm ready for it to end.
Yeah, no kidding. You going on vacation after?
No,
Oh.
if I going back to that 8-hour workday would be vacation.
Yeah. Yeah. And Mike, how are you doing?
Good. Yeah, I do 2 weeks on, 2 weeks off. So
Right.
12
There you go.
No, it's happy, man.
Yeah, I'm
I
on
get
8.
2 weeks off. 2 weeks off coming up here on Wednesday. So
No, I'm on 8 to 5, so my weekend's my weekend. Work can wait.
Yeah.
Yeah.
I don't know, with our department, we've either got to rotate who's on call, or if the shit really hits the fan, then it's you're gonna get out here.
We're almost ready, I think. A couple minutes.
yeah, I made changes to that folder. Did you guys? I don't know if you guys got those from the folder as
Right.
it is now. Or I don't know how that affects.
Sorry, I think I forgot to. Share the share link. Here's your part, anyways. Okay, awesome.
Yeah.
Looks like you're mostly done.
Kind of trying to figure out inputs or outputs because it all depends on what perspective.
That was
But,
segment 7.0 requirements.
Might be 3.0.
Oh, yeah, it's just, I think it's backwards in the project guide. I'm just waiting for it to go 900. Okay, we'll start. So this is the first meeting for segment 2. We have a little bit to cover today, but not a crazy amount. Oops, that's the wrong place. Let's look at the last meeting minutes. Well, you guys were all here for that, so we don't have to go too crazy with it. We have Alexi is doing context analysis. Steve is doing alternative solutions. Mike is doing requirements analysis. And it looks like you're both, well, mostly done, right? Or you have a good skeleton done anyways.
A skeleton, yeah, a bit more to do yet.
Okay, well, that's pretty much all we had to talk about. And we also did the... So I have been working on this a little bit. I haven't gone too crazy yet, but I'm making more progress. And it seems like it'll be actually useful for managing the project. So, and last time we looked at the segment 2 guide, and that's how we assigned all the responsibilities and the template. And it was only an hour. And I did post to the forum about segment 2, I believe. And this week I'm going to try to get the video up. Okay, so that's about it for that. Review segment 1 final submission. So let's take a quick look at what actually got submitted. It was this. Except that the names are obviously there in the real submission. So me and Zane moved it over to the template. He wrote up. This was after what we did after the meeting. We moved it to the template. We put in the copyright thing. He wrote up the participation report, which I really didn't look at that closely. I just trusted that he did it correctly. And a little summary there. Overall group participation was positive and many interactive discussions were held. And that's right. So this is where it starts proper. Our cover page, table of contents, table of tables, table of figures. And pretty much all of this wasn't changed. This was just tightened up a little bit to fit the template format. And we deleted the other revision table and just had one. And I submitted it, I think, 2 hours before the deadline. So we were good. And I have not received anything back yet, like any feedback or anything. So I don't know, like, do you guys see the submission in your Moodle? Like, is that folder shared between us, or?
I'll check now.
Yeah.
So,
Lower your pants down.
Yeah, 3 screens.
3 screens. Can you guys see
No.
that submission? No? It doesn't appear for you?
No,
it's
not there.
Okay.
By 4 days and 15 hours.
It says it's overdue for you?
yeah.
Well, because you just didn't submit, but...
But I think this depends from...
Okay, well, here's the proof that I actually submitted it. I don't think there's anything incriminating on here. Or oh, shit, my last name. Shit.
It should be okay. Oh, yeah.
Yeah, so it was submitted, just so you guys know.
Yeah, because the instructions clearly say that the project manager or leader should be the one that submits. I don't think everybody needed to submit.
Okay,
So I'm not really for sure how that works out.
Yeah, I did it, so that just so you guys can rest assured that it actually happened. So we can, well, I'll leave that open for now. Okay, so that's done. So that's the review done. Dropbox access, right. So this is the Dropbox, and I screwed up because let's just go up. Up. Oh no, up. Okay, module 5. That's like the top level folder. I only shared this one. So I should share this share link, right? Oh, whoops. I shouldn't have done that because it showed up on the display. Okay, I'll share that one to the teams, which I can actually do right now because that's on a different display. There. Okay, so that should be the whole... So now the top level folder is shared in Dropbox with you guys. And it should like show up as shared. Well, whatever. Yeah, because you posted to... or no, I just made that one this morning, sorry. But if you want to keep using this one, that's fine, whatever. I'll just see when something gets uploaded. Okay, so Dropbox Done. Okay. It's unfortunate we only have like half the group here today, but it's not a huge deal. Okay. So this order, like this one, this order does not really work, right? Like we can't do it in the order of, like we can't do the executive summary before we have the rest of the thing done, right? Like we have to finish everything first. And we can't, like we kind of talked about this last week, we can't analyze the alternatives before we've generated the alternatives. And we can't generate alternatives really before we know what the requirements are. And we can't know right? So like this order has to get kind of mixed up a little bit. So I did that and I kept it pretty linear. Like I'm not going to try to do stuff in parallel yet and with like a bunch of nested tasks, and like you can't make closed loops for tasks and stuff. Like it's possible, but I don't think it will permit you to do that. So this is our top level structure. I haven't filled in everything yet. Like segment 1 was kind of a wash. I'm not going to go back and try to fix it because we finished it. But segment 2, it gets a little more complex now, so we have to kind of start trying to get a grip on how we're doing things, right? So we're starting roughly today, and we're ending roughly on... the weekends kind of screw things up because it deletes those 2 days, but don't worry about that. As long as it's roughly right, it's fine. I'll tighten it up later. So we've got roughly 6 weeks to finish this thing out from now. 5 to 6 weeks. So here is our different stuff that we have to do. We are here. This is sorry, I'm still figuring this program out. We are here. This is today. So I made myself a little thing. I'm going to try to manage myself too, because there's like lots of little tasks that I have to do that I forget stuff all the time, right? So segment 2 meeting is work in progress. Post meeting, I'm about half done. Well, we're about 10% done, whatever. After the meeting, I have to write the minutes for the meeting. I have to post the minutes to the forum. I'll probably post in the Teams chat too, just to remind everyone that it's there. I'll post the minutes into the Dropbox. And so that's kind of that task. And I'm also going to finish out this chart for segment 2 at least. And I'll try to get a little more detail for each person's part. And if you've already done your part, I just mark it as complete, right? But I kind of want to granularize it and stratify it a bit more, because it's going to get, like last segment was easy. This one's a little harder. The next one will get probably more complex. I haven't looked at the segment 3 guide yet, so. Oh, Rincey's here. So it's unfortunate that Dino isn't here, but that's not a big deal. So he has the first thing. He has to do the problem definition, and everyone else kind of cascades down from him, right? So I think instead of everyone trying to do everything at once, don't waste your time. I'm going to allocate about 3 days for everyone to do their part at like a specified time. So if you want to kind of write a little skeleton, fill in the blanks thing between here and there, that's fine. Like, do what you want to, but you'll get your input and you have to generate your output to the next person within 3 days. Does that sound fair? because it's like there's a lot of group members. Everyone needs a job, and we need to kind of structure the whole process a little bit, right? So
Is it by Wednesday or?
no, we'll go through everyone's kind of due dates. So
right.
so Dino, he is allocated only so. So I can't change anything date-wise here, right? Because this is not the task. This is just like the group of the task. This is his actual job. Adapt problem definition from project charter. I'm going to give him 3 days from the 20th to do that. So he has to finish that by October 22nd, which is in a week. The dates don't quite work, but don't worry about it too much.
Elliot, can I ask you something?
Yeah, go ahead.
Do we know or have we finalized what we are proposing for this project? Like, because from my perspective, I'm pretty blank with electrical, especially solar energy. All I know is we convert sunlight to electricity. I don't know anything about from that. So if we have technically finalized what kind of solution we're proposing for this remote village, will it be possible for someone to share with the group what we're doing so that it's easier to work on this written, because the written work is like the second part, right? First part is technically we all should be on the same line. We should know what we're actually proposing, right?
Right. Yeah, we can kind of cover that in the second half. We're just going to quickly zip through the structure of this segment. We'll only spend like 5 more minutes on this. But that will come in the kind of this part of it, right? Okay, Alexi, you will take Dino's output and you will do something with it, generate the context analysis, and you have to do that by October 27th. Mike Sovereign is here.
My part is pastel.
Yes.
That's what I'm doing. That's what I'm doing now.
Right. Yeah, but like if you're done, or if you have the skeleton, or if you just want to fill in the blanks, then as long as you have your like final part done by October 27th and ready to give your final version of it to Mike Sovereign, then everything will work out fine, right? And I'll kind of be on people during your like little window, asking you, hey, where's your output? Did you get your input? And I'll be keeping track to make sure that you have what you need and that the next person's going to have what they need, right? So that's kind of the job that I'm taking. Next one, Mike Sovereign, you'll get your part on the 28th, and you got to get it out by November 1st. Steve, Alternative Solutions. Mike's going to give you something on November 2nd or before, and you got to get your part out by November 4th. Zane isn't here, so we won't worry about him. He's not here. Rincy, you will write the executive summary, so don't worry about it too much yet.
Okay.
You don't have to worry about it for a month. You'll be kind of the last person generating real content, and then Aaron, it'll probably be me, will be doing the proofreading. But I'm not too worried about that. And like the dates are rough, right? I actually have to do the submission on the 22nd, but I'll tighten this all up. So then I'll do the submission, and we'll have meetings between here and there, and we'll kind of update on progress and stuff. So that's it. That's all for the kind of Gantt project review. So Rincy, last time we had to delegate you the executive summary job because you weren't here. So we just needed to give it to somebody, but yeah, you seem like a good candidate for that.
No problem.
Yeah. So you'll do that last.
Okay.
Dino isn't here, so we don't really have to talk about his thing. Alexi, kind of sounds like you've made a little bit of progress on your pestle analysis, right?
I'm on the letter E now.
Okay. Oh, the first one or the second one? Oh, okay. The first E. The second E. Oh, okay.
Done it, yeah.
No, that's good.
So,
awesome. So
week,
I'll mark you as pretty much done.
sorry, Elliot. Next week I'm off, so I think I will do it next week.
Yeah, for sure. Yeah.
Not given any dates now, but I try to put a draft version. Next week. Yeah.
If you get like drafts and stuff, if you want to do it before your like formal window, that's fine. Go for it whenever it's convenient for you, right?
It will be better.
I'm counting on the formal windows, right?
Okay.
Because there has to be some kind of due dates for each person's thing. So maybe like how I'll do it, depending on what state your part of it is in. At the start of your due date, I'll take what you've got, I'll look at it, I'll kind of review it, if there's problems with it, or if there's something else needed, or I'll look at the next person's thing, I'll look at the person before things, and manipulate it or whatever, and by the end of your window, it will be ready to hand to the next person.
Right.
So that's the due dates thing. Okay, so we covered your thing. Requirements analysis. Mike Sovereign, what progress have you made? You posted it a few days ago, I believe.
Just last night I did, but it's there's a bit of technical stuff in there. I'm just
that's good.
Kind of thinking about what exactly we need. There are certain things like when you have batteries, you're going to probably want a backup generator because you can't let the batteries go dry.
That's right.
Battery.
Yeah. So with like lead acid batteries, for example, like maximum depth of discharge for a deep cycle is only like 80%, right? So you can't bring it right down. So that's what you're talking about. Or you'll have to. Did you guys look at that open solar thing at all?
What's that?
I posted a link in the chat. It's just called Open Source Solar, and it's just like solar power for dummies, right? Like I really knew nothing about it. I
saw it at one point, and then I missed where it was.
Yeah, and then I started looking at that, and I was like, there must be like a big market for home gamer solar power, right? So then I just started Googling around, and honestly, I just filled an Amazon shopping cart, and I was like, oh, these are all of the parts that I would need to do this. I would just need to buy more of them. I'm probably not going to buy them from Amazon, right? But it was just interesting to see, like, okay, you need an inverter and blah, blah, blah. You need fuses and the panel and the connectors and the cable and stands and the charger, the solar battery charger. I can't remember what it's called, and GFCIs and blah 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 and all that kind of stuff. So it was just and thinking about kind of the details of solar, there was also a bunch of like good tools like solar insolation calculator, geographic. And it would give you like an estimate of how much power you could produce monthly based on your location. It was a really powerful thing. So there was a lot of good like math tools on that website too that is worth looking at. Like all of the basics, I'm sure you guys are very familiar with, right? Like watts.
Guys, I
and
just put
ohms
on that chat useful link. Just see it, Elliot. It's already systems.
I see. Photonic
in the conversations.
Yeah, perfect. Yeah, I was looking at sites like this too with like commercial packaged systems.
Yeah.
And a cart with batteries on it. What are those? Probably lithium iron phosphate, right? Yeah. Like this is perfect. Perfect. Why do all the design work yourself, right? Someone else has already done it. And it looks like it comes with a quality, all-in-one charger controller thing. Hybrid inverter, I guess they call it. 600 amp hour batteries. So yeah, this would be a great. I mean, I don't want to do the whole design project why do it again? Someone's already done the work to put all
Like
that
that-
package together,
That
right?
will be useful for you.
Right, yeah. It's
Yeah.
like for someone who knows very little about this and doesn't really care to learn more about it, I just want the results. Perfect. So,
There are a few other little things in my. I was talking with a friend who
Right.
does sales. How, if this is more something to consider, but it's part of my requirements analysis in terms of packaging. Just trying to get things delivered during COVID and with the supply chain issues and how that
right.
costs. So that's more in segment 3 or 4.
Yeah. At least it's
but
like
it-
a non-perishable thing, right? So, shipping
Then
is
there's,
backed up right now.
I was thinking in terms of safety too about like unauthorized modifications. Like people are going to come up and they're going to look at this and they're going to say, "Well, we got 240 volt power here. I'm going to add my own receptacle."
Right.
Well, we don't want
right.
people to add their own receptacle. So if we, for safety reasons, decide to add a receptacle or two so that they don't do it, it would be more on the safety side of things.
Yeah, that would be like a risk thing. Let's quickly just run through your whole output here, Mike. So, solar panels capable of charging 1,600 watt-hour batteries over 10-hour day with cloudy weather. 1,600 watt-hours. So that's about 12-volt battery at about 100 amp hours, roughly speaking. So only one. Okay. And just for some context, because I kind of forgot, a 60 watt equivalent LED bulb uses 8.5 watts. Those are the ones I just bought from the grocery store. So that's just to give you some context. Backup generator, well, we'll have to maybe reevaluate that one because I'm not sure about that one. But this is just rough, right? 200 watts while maintaining a minimum of 50% charge. So let's bring up our friend here. 200 divided by 8.5. 23 bulbs for 15 people, 15 houses. Maybe not enough. We can bump this, but it's just a multiplier, right? If we want more power, we just multiply things. So it's easy. But we have this requirement now, right? So that's good. Batteries capable of delivering 200 watts. So 200 watts. Oh, right, I already did that. While maintaining a minimum of 50% charge. Sure, if it's a lead acid battery. If it's a LiPo, it can go way deeper than that. But that's reasonable for lead acid. Charge controller, yeah, we need that for the panel. Inverter, right? So if we're going to do AC power to the hoses, we haven't decided that yet. But it will be either inverter or a DC, like boost buck converter, or whatever it's going to be. 15 high efficiency. Oh, there we go. 12 watts. Okay, so that's 100 volt or 100 watt equivalent. Capable of producing 800 lumens. Sure, if it's only 15, then that's okay. But bear in mind that this system is going to have losses. You're going to want lights in and around the solar compound or however it works too. If it's a little building, it has to have lights in it also. And maybe some other equipment. And it would be nice to have a little bit of buffer, right? Provide ambient and reading light for 15 dwellings for 4 hours a day. So 1 kilowatt grid, that is roughly 10 kind of standard size panels. The panels are typically 100 watts.
That's about four panels. Panels usually now about
250
watts.
Yes. Okay,
that's 4 panels.
Yeah,
that was just a statistic I pulled off a webpage, which is linked at the bottom.
Sure.
So that's just to give context of how much charge we should expect.
Yeah, because the panels are about 1 square meter is about 200 watts because they're about 20% efficient, roughly, maybe 15 to 20, from what I read. Oh, Michael, Showmakers. Right. So rainy season construction start date. Actually, from what I was reading around, like overcast days and rain, and like unless it's really thunderstorm and it's totally blackout dark, being overcast outside doesn't really affect the performance that badly. Like you might go down to like 50 or 60% production versus normal, but being overcast, it's not that bad. The website with the tools on it, which I should bring up here. I'll let you guys have a discussion. I'll Google around and find it. It showed you like daily and monthly expected, and even like the angle that you're supposed to mount it at, and like it was really powerful. So wild animals and domestic, right? We have to probably put a fence around this stuff. Dust, again, since it's so rainy there, dust shouldn't be a problem.
Too, though, like the rainy season and the dry season.
And actually, you'd think that the equator would be the best place for panels, because then you just mount them horizontally. But that causes a dust problem, right? Because then water won't wash the dust. So there's actually a minimum recommended mounting angle for all panels, right? They have to be up like that somewhat so that rain will wash the dust off. Packaging issues. Locally available products. What do you mean by that? Like you mean like
a supplier, I should say, like somebody local from Freetown or something that supplies the product.
Yeah, it looked like there was some solar suppliers around there. Actually, I was looking around. I think in Freetown. No, it was in Johannesburg, right? Because I googled that address. I googled out of curiosity the address that we put down for our company, and because I had been googling like solar stuff before, it showed me on Google Maps that actually quite close to our company's address there is a solar power supplier in Johannesburg. Interestingly, just kind of coincidence. But yeah, we'll have to. I'm sure that there's an electrical contractor somewhere in Freetown or Boattown or whatever. And we'll just Google that. That will be part of the procurement phase. Shipping to the village from Freetown to Yele to Bow Village. Okay, logistics. Right, so we need to know what kind of road it is. So that will be just kind of following Google satellites. But I've watched some documentaries and stuff about shipping in Africa, like road shipping, and it's pretty bad. It's like mud bog to get everything everywhere. Current market conditions, right? COVID is a problem. Gas shortage. Okay. It could kick our ass. Yeah. And, okay, hard-packed earth. Is it going to be hard-packed there? I don't know. And it will probably be hard to get heavy equipment in there, right? So it'll basically be manpower installation.
I found also, guys, screw-in piles which you can screw basically by manpower.
Yeah, you can just screw them in with a big bar, right? Yeah, that might be a good thing. You don't even need a motor or anything.
Piece of pipe with a screw on the end which you can screw manually.
Yeah, that probably. I can send
link as well.
Yeah.
For that.
Yeah, the less concrete and stuff that we have to haul in to do this, the better. So even like a chain link fence might not even put concrete piles in. Might just put the posts right in the ground, which it kind of sucks. But even with the screw piles, I think screw piles are supposed to cap them with cement. But
it's basically all you need. Screw-in pile and a jack and a two-man. That's it.
Oh, okay, perfect. Yeah, so that could be the kind of foundation of a little building and fence foundations, or for the panels themselves, right? Mount them right on screw piles. That would be really easy. Okay, so we'll look at that for kind of all our alternatives analysis, right? How do we mount them? And that will be part of this, right? Because once we start getting into the real design work, this is going to really like flare out, because we're going to have to think of everything. How do you mount the panel? Do we want to use concrete forms or big frame or just a screw pile or whatever? And then like there's going to be so many things to consider. So that's where doing this is going to help us out a lot. Anyway, I'm just rambling. Wooden elevated enclosure for electrical equipment. Wood's probably a good choice. It looked like it was a pretty forested area, so.
Sunlight isn't as much of an issue as I thought.
Yeah, shouldn't be a huge deal. Maintaining battery charge to prevent dead batteries. Yeah, so that'll be another choice that we have to make, is battery type.
Guys, here's the second link.
Sure.
Just how it looks like. These piles, and basically little frame for panels itself required, to.
Yeah, this is exactly what I was thinking of. I always imagine them having a screw all the way up, but the screw, there's only like one flight.
I think I have a coworker who can read that.
Yeah, so do I. Well, actually, in this part of the world, like Ukrainian and Russian is pretty common. I don't know what language this is.
That's quite popular in Russia.
Yes.
That's why they use this a lot. It's,
hey, look at that.
Yeah, perfect. And fence is also possible to do with that. So. Yeah,
I'm imagining a piece of barbed wire up here. Actually, I really don't want people messing with this stuff. Mm-hmm. Anyways, yeah, that's perfect. Those will probably work very well. Maintaining battery charge to prevent dead batteries. So. I'm pretty sure that we're pretty set on solar. We will give the wind and water kind of, it's on the tip of my tongue.
Consideration?
Yeah, but not like real consideration. We'll entertain them, but we're probably not going with those. We're probably going with solar. And we're probably going with battery storage for energy. I don't think we're pumping water up into a water tower and then bringing it back down. And I don't think we're going to put a big flywheel in the ground, right? I think we're going with batteries. So that's what we'll entertain those other ones, maybe. But so we're going to wind up on batteries. Batteries, there's 4 types. There's 2 main categories, right? There's lead acid and there's lithium. Lead acid, we have flooded, gel, and AGM. Flooded, cheap, high maintenance. AGM, low maintenance and kind of intermediate cost. Gel, very low maintenance, very slow charging, and very expensive. So so gel is pretty much out of the question, I would say. It'll be between, for lead acid, either flooded or AGM. I think that's advanced glass mat or something like that. Lithium, there's only one option for solar, lithium iron phosphate. Very low maintenance, very lightweight, very high energy density, difficult to charge. You need a special charge controller, right? And very expensive. So we will be basically between flooded lead acid, AGM lead acid, and lithium iron phosphate. So those will be our 3 options. The first 2, lead acid, they are simple charging. You could literally hook them up to, come on. You could hook them up to a 14.3 volts or whatever DC power supply, and that would charge them quite reliably. Lithium batteries require a little more finesse to charge. But anyways, that stuff is all just details. Safety issues. Children, right. The people that everyone always forget about. kids will be very curious about whatever we put in. It will be a very unusual and strange and magic-looking thing to them, and they'll want to go in there and start playing with wires and jumping on the panels and shit like that. So they have to be, one, prevented from damaging the equipment, and two, protected from the equipment, because it's going to be live electrical power, right? So that means locks on stuff, a fence with a piece of barbed wire on it to keep kids out of there, and maybe some other unsavory people if they want to go in there and start messing around. And locks, right? I said locks, and maybe security fasteners so that you can't just open it with a regular flathead. Fenced in areas with lock, right? Yeah, we don't want everybody going in there. IEC quality equipment. So my idea of buying stuff off of Amazon.China is probably not going to be a good idea. Fuses or breakers, yeah, everything needs. So right, with solar panels, you how you do it is you wire like 3 or 4 panels in series to get. I mean, it depends. Like, they're nominally usually 12 volts, and they have internal protection diodes so that if it's got partial shade or if one bank of the cells blows out, it's kind of protected against short circuit, right, or whatever you want to call it. So you wire 1 or 2 or 3 or 4 panels in series to get 48 volts, 12 to 48 volts. You put typically about 4 to 6 of those series banks into a junction box. Each bank has a fuse. The junction box has overcurrent protection. Then out of the junction box goes into the battery charger controller, and then into the batteries, and then into the inverter if you're using one, or just straight out if you just want to use DC, or you want to regulate the DC a little bit, or whatever.
We did it slightly other way, Elliot. Basically, every inverter has a maximum input voltage. It's usually till 1000 volts DC.
Oh, okay.
Yeah. When I worked with the solar panels, so I work on a commercial roof. So installation was about, I don't know, 30 kV, about 50 kV, something like that.
DC.
And 30 kilowatts of power from the installation.
AC power coming up. Okay. Yeah.
Yes. So we wire panels in series. Panels is about 30 something, 40 something volts each.
Okay, so you'd have about 30 panels in series.
So in series we put about 20 panels.
20. Okay.
Then it called string. Then this string of DC go into the inverter, and we had about 4, 5, 6, 7 of that strings.
Okay.
In a parallel to the inverter.
And that was generating about a megawatt. Is that what you said last time?
No, the biggest project I participated, it was a solar farm. Total capacity of 8 megawatts.
Okay, so yes. that's megawatt scale.
Yes. Yes. Okay. We not talking about this. We're only talking about the principle. That's right. Basically batteries going into the series, not to exceed maximum input voltage for the inverter, and then AC going out from the inverter. And I think the DC power should go on batteries from the inverter as well.
Yeah, like the charger. Yeah. Charge controller. Okay. Yeah. Like I'm thinking that probably 1000 volts DC is. We'll look at it with the risks, right?
200 volts we'll be having about. Sometime.
Yeah. Yeah, we'll have to kind
Even
of
less.
decide. So I guess that will be one of our. So we'll have to come up with a table of design criteria, right? Maximum DC panel output voltage, and then everything after that. Yeah, I guess that'll just be a kind of decision that we have to make, right? Because I don't know what's safe for DC voltage, like 24. Yeah, how much? What? 1,000? What'd you say, Mike?
I said 24 volts is safe. After that, you're starting to get into...
Yeah, 24 is safe. So probably 24 is reasonable. And then it's kind of nice that you can operate a bunch of PLC equipment on 24 also, right? So.
I have a book that I took solar installation courses a long time ago.
Okay.
I never kept going into it, but I still have the book. So it's at home. When I get done at work here, in 4 days, I'll be able to pull it out. It's like a textbook. It's awesome.
Awesome. Yeah, that'll be a really useful resource.
Using that to do a lot of my design when I get back. What about those things, like, I don't think we'll need them necessarily, but there's you put them on each solar thing so that if you lose one of your solar panels, your other ones don't get affected. Because if you have all of them put in series and you don't have this thing, I forget what it is.
A protection diode or something like that, or a bypass diode or something.
For protection, but each cell, if you lose one cell, then all your cells will be affected.
Yeah, so like each panel has multiple, like 3 different banks of cells, right? And losing a cell doesn't mean like it gets smashed by a baseball. It could just be that it gets shaded out by a bird or something, right? And I think it was a bypass diode inside the panel that it does it like automatically or something, but we'll have to kind of look at more details.
Yeah, they're very expensive. You don't have to add them when you can, but it does. I'll look into it. I'll get some more information on it.
Yeah, that'll be part of the more formal design, right? Is kind of doing it'll be part of our HAZOP, I guess, is what happens if you lose one panel. What happens if one panel just stops producing power for some reason? Is it going to burn down the whole building, or so we'll have to kind of figure that out. Anyways, we were here, fuses and breakers. Yeah, so that'll be part of the HAZOP and stuff, and tampering. Yeah. Maybe have a receptacle, right? So someone might need to, or I mean, someone might just want to use a hand drill inside of there when they're installing it, or putting whatever. Like, it would be useful to have receptacles. So, and we'll be kind of deciding on how big we want to go. Okay, we'll talk about that in 1 minute. Maintenance issues, training, spare parts, easily sourced parts, contact for support, and resource map. We only got 15 minutes left. Sorry, I'm kind of being long-winded this time. Solar resource map. Yeah, perfect. I also had this. It was...
So we're in the yellow band of that map.
It was called the EGIS. Is that what it's called? Oh, it's called the EU Solar Insolation Tool.
Having a hard time getting on DuckDuckGo. I use Google too much. I'm used to it.
Oh, yeah. Yeah,
but I hate it. I don't like Google.
It's nice that you can switch your reason. There we go. PV Performance Tool. This is what I was talking about. Loading. We are right. I think that should be... Where is Bowtown? We are about somewhere up here, I believe. I'm not sure exactly. Here's the database we're using. The panel type will probably be crystalline silicon because these are very, very expensive. And these, I think, I believe, are moderately more expensive. Peak PV power. So we want 1.6 kilowatts. System loss, that's just default. Mounting position, freestanding, sure. Slope, no, we want to optimize slope and azimuth. And we don't care about the price. There we go. Our lowest production will be 150 kilowatt hours in August. And we want to mount the panels at 12 degrees, and we want to point them to 8 degrees. Yeah, I guess. And yeah, there you go. That's
really
radiation, cool. And that's PV output. Yeah, it's, I mean, why do all the work yourself, right? There's stuff for it. And there's a bunch of different options here. Daily data. I mean, this should be pretty obvious what the daily, month. Yeah, let's look at August. And you must just select an option from above. Irradiance, sure. So that's what we look like during the day. That should be pretty obvious to everyone, right? So it's about noon, 1 o'clock, it's the highest, and then obviously at night there's nothing. So just bear that kind of stuff in mind. It's not like a coal power plant. It's very different. Monthly. Okay, so that's a good tool for that.
We could have done a coal power.
Yeah, well, hey, analyze it as an alternative, right?
Boiler and everything.
Yeah, it's way easier. Okay, so we covered your part, Mike. I just kind of went into depth on that because you had it done. Steve, alternative solutions. So you'll be looking at those, just come up with a bunch of different options, but I'm pretty sure we're going to land on solar power, right? With battery power. Yeah, I'm pretty sure that's where we're going to go.
Yeah, I just took what we jotted down in the last meeting.
Right.
Our little improv brainstorming. And really that section, I mean, it's fairly easy. It's given just brief, not even detail, just brief description of alternative solutions. So there's really nothing I have to go through and just kind of explain a little bit. Nothing really too crazy.
Yeah, and you got some time to do it, right? So I'm only going to be hounding you when it comes time for your
like I said, I took the ideas we come up with and just kind of just gave an explanation or more of a not detailed, but just pretty basic of what they are.
If you want to, I think like the guide wanted you to kind of tabularize it, I believe. Yeah.
No, that's alternative analysis. The other one was just it's really, which we already did it. We did the brainstorming, you could say, the last session. And we all just kind of jotted down a few ideas. So I just took those and just gave a little bit more of an explanation of them.
Yeah, sure. Okay. It sounds like you're on the right track. Next.
Yeah, well, that being said, if there's other stuff with people's, because I don't feel like mine's got a whole lot going on, so if somebody needs some assistance or feedback, or I can talk to anybody, if they need some help on their part, I have no problem
for sure
contributing.
Yeah, we got
Steve. Sorry, just wondering if you've uploaded that work you've done yet, just so I can make a start on the analysis of your alternatives.
No, I can. I just had a couple more to go through, but if you look back on our last segment when we documented, I just took those same ones.
Yeah. Okay. Cool. All right.
Awesome.
And two, if you have any other ideas to keep it, because I don't know how far in analysis you have to go for the alternative. I mean, for me to make it just simpler, if we have other ideas, I'd hate to put an idea out there that's going to involve having to go through a whole explanation of the solution. You know what I mean?
Well, let's just start throwing some stuff out. Did you look at like packaged versus custom?
Well, so the ones we come up with when we last spoke was solar wind, AC versus DC, the centralized versus individual, and griddable, not griddable. And I think we had a couple others.
Custom or package.
Yeah.
Photoelectric versus steam. Like steam, I mean like reflector onto a boiler, right?
Yeah.
And hydro.
I think like Alexi was saying, mostly that's used for heating. The solar steam is not for power as much. Yeah,
and that might be how they do it in like Nevada.
Like the geothermal.
Yeah.
I checked that out. I looked at geothermal.
Are they like eligible for that or no?
They're 0%.
Oh, okay. Their elevation's too high.
So we could be pioneers.
Yeah. Okay.
Yeah, and really, I think the actual guide just states what do we need, a minimum of 3.
Oh,
so
okay.
Take it easy on ourselves.
Yeah,
I mean,
let's just
put
do
a
the
whole
minimum.
list, but then again, Mike's going to have to go through and analyze all
Keep
these.
it simple. Simple.
That's why I just took the ones we spoke about last time and
Okay.
just gave it a brief description of, that way somebody who reads it go, oh, okay, that's what you're talking about.
So it sounds like you're pretty good. Okay. Project risks. Well, Zane's not here, so I'll start hounding him a little bit. Analysis of alternatives. Mike Schoenmaker. What is your progress, or what's your prognosis, or what?
Not good this week. I've been working around the clock at work, so I haven't had 1 minute to even look at it, to be honest. But today I'm gonna have,
Okay.
So I'm gonna have a bit of time today to look at it, and tomorrow. And I'll
just mess around. No pressure, right? We got a while, so. But I'll start. Yeah, so you got a while. I'll start bugging you in like a month.
Yep.
So.
No, that sounds good. We've got plenty of time.
And Rincey, executive summary. You pretty much have to wait. You can start roughing. You can start roughing it out, but don't go crazy with the details because we don't need
like
that.
How I mentioned, I'm not very clear about the technical solution that we're going forward with because I'm not quite experienced on electrical at all, especially solar.
Okay.
So I went through a couple of sample executive summaries that have been prepared for similar projects by such similar companies. So just to get an idea of what kind of information I need to include in the executive summary. So I've just had I briefly read, I think, 2 or 3 summaries. That's it.
Yeah, so I think if you look at the WikiHow, it's pretty good. Pretty much it's just what's the deal? It's the short form. You should understand all the major points of the rest of the document without having to read the rest of the document.
Correct.
From reading the
just like how you
executive
write
summary.
the first summary before you publish a paper, right?
It's a summary written for an executive. Someone who doesn't want to read all the technical mumbo jumbo because they don't understand it. They just want the short and sweet of it, right? So.
Yeah, so we should know the actual solution that we're all doing.
Yes.
I heard a few names you're mentioning off grid and all that. So whatever it is, I need the final thing.
Yeah, well, you just leave it blank, right? We have decided to go with AC or DC and just put a question mark, power distribution system. We have decided we are going to or not going to integrate the system into the grid. And then once we know, we just select and fill in the blanks. And the power requirement will be blank watts. And we will need blank amp hours of batteries and just, fill in the details or whatever. You're free to do as you please.
Yeah.
Next one. Proofreading. Well, I'm kind of thinking it might wind up being me, but it's okay. I like doing stuff like that. And final submission. That one's obvious. Before the next meeting, I'm going to break this stuff all out for you guys, and we'll go over it at the next one. But no huge pressure, because we have roughly 5 to 6 weeks to do this. So, okay, the floor is open. What's up? Anyone? Questions, comments, concerns, doubts?
Are we having another meeting next week?
Do you guys want to, or do you want to take a week off?
If you're going to go through and kind of put dates on what we need to do, I mean, I don't see a reason.
Yeah, we can take a week off. We'll reconvene on the 30th. Oh, Halloween? Oh, yeah, no, that's not Halloween. Yeah, the 30th. Sound okay?
Yeah.
That sounds good.
Yeah, we'll take next Saturday off. Okay, so next meeting on.
And I think we're all pretty good about getting messages across the forum. So I mean, anything that's uploaded or posted, everybody can see and go on.
30th. So we looked at all this stuff. Project risks we didn't look at, and problem definition. But this one is pretty much done, right? And this one is fairly obvious, and it's not the job of anyone here, so there's no sense in going through it. Okay.
You tried to hold it, Aaron?
I did. I emailed him again. I'll email him again, but I don't know. He's just not replying or anything, so we'll figure it out.
That sucks.
Yeah. Well, it sucks mostly for him. No big deal. Okay, anything else? Let's just throw around some ideas for the next 5 minutes. We're done. So we're done talking about the minutes for now. Anyone have any kind of ideas or like technical ideas? I mean,
I might try and get it together like once I get home anyway, to get together kind of a little bit of a drawing of the of equipment that's going to be involved, and that way too it'll help everybody put things into context.
Right.
But yeah, again, I won't be able to do that till Thursday.
Yeah, sure. I'll put it on the Gantt chart. I will. Yeah, I'll try to. That'll be my part of it, is kind of managing. And so once we have that drawing, how we'll break it down is we'll break it down into the different parts, and then selecting like an option for each of those parts will be like a sub job, and those can get delegated. But that's we're talking way in the future, right? So yeah, no, that'll be useful. Yeah, I mean, I've been messing around making drawings and stuff too, just on loose leaf. Just kind of.
Yeah, it's not gonna. I'm not gonna go with a supplier specific.
Yeah, that's and
just the basic equipment and everything, and then we can go through that in the next segment when we when we actually have to do that.
Yeah. For Rinsey, you mentioned that you don't know much about solar power. I strongly recommend you. Like, neither did I really. Like, I kind of knew how it worked, but I would say I'm like at beginner level now after going through that open source solar website. There was lots of stuff that I hadn't really considered before, and I didn't know much about the equipment, but now I think I could put a solar system in my house like tomorrow. Like, it seems quite simple. Yeah. It's just all the little details. It's just all the little details, right? Like, and knowing what kind of like a stupid example. M20, I think it's called the M24 connector. That's like the standard solar panel wire connector. And it seems like 10 gauge wire is standard size. I didn't know that before. It's just, okay, that's just what you use. And it just makes things simpler, right? So, yeah, just go through that website and just, it's kind of written for...
Yeah. I'll be doing quite a lot of reading. But just to understand, so I know that we're discussing several options, but when exactly are we finalizing, like, what are we going forward with?
Right, so I'm going to start hounding Dino like pretty much right away, because I need his thing by the 22nd, the problem definition, right? So he's just gonna take the project charter and just adapt it into a problem definition for this segment. So his part is quite easy. It could basically be just the charter again, maybe with some more details. So that will be the first thing that I need. Then Alexi will give me his PESEL analysis, right? And he'll give me that on the 27th. And then...
I hope I'll be earlier.
Yeah. And please put just anything that you're working on, like work in progress, put it in the Dropbox, right? Because then everyone sees it and everyone's kind of more confident about what, and then I can kind of check your progress too and see if you're going in the right direction or what's good or.
I can put it right now.
Yeah, for sure. Yeah, it's free to use, right? It's a work in progress thing. So, and like Rinsey, I think what you're asking is when are we going to wind up on our final system design selection.
Yeah, I mean, what we're discussing now is document submissions and the actual written work, right? But just for our knowledge, what exactly are we finalizing? What's the solution that we're finally going ahead with?
So I think it's going to be solar power, battery power storage. Whether it's lithium or lead acid, haven't decided yet. I'm thinking we're all leaning toward AC power distribution at 240 volts. I think that's what we're leaning toward, right?
So who among the group is more experienced in this sort of a project?
I think it's Alexi, and I think Alexi has the most solar experience. I have none.
Okay.
I'm just pasted in the so segment 2. I just paste what I done as for now.
Awesome. Excellent work.
I got a little bit, but I haven't used it for 7 years, so I never did installations, just courses.
Yeah.
Also, the second question, guys, how we deliver power to the houses?
Yeah, so that will be another thing, is do we want to do above ground poles or buried cable? I'm not sure.
I thinking that the cheapest solution will be buried cable.
Buried,
because if we put in like ear line, we have a risk of damaging cables. I don't know, through the animals. I don't know, kids, something else, and buried cable will be underground. We can use unqualified local workers to dig trenches.
Yeah, that's right. Yeah, and it never freezes or anything there, so you can bury them 2 feet underground.
Maybe cable will be a bit more expensive, but I don't think we will go more than 4 mil cable. It shouldn't be very expensive.
Yeah, like it'll have to be like armored jacketed burial grade cable, and
maybe steel wire armored or
aluminum.
Just direct burial.
Yeah, just direct burial cable. Yeah, that's very common.
Yeah, we had discussed aluminum because it's also
cheaper, but someone, I believe it was someone voiced a very strong objection toward that, and I'm not sure why, but I think it was Zane.
I think for theft. I think with the
copper's more expensive. That's why I was kind of suggesting aluminum, but I know aluminum is really shitty to work with. Like it's really difficult and miserable.
Copper.
Yeah, copper's way better.
We'll be having a lot of problems, and probably it will be more difficult to buy because nobody uses it.
Yeah, that's right. And so the buried cable will probably be stranded copper. What gauge? I don't know. That will just be. It'll probably be pretty light. Like just.
I think that'll
it's
help
only
with
15
this
houses.
theft concern in that country or area. I mean, if we're burying it, then I mean the likelihood of that actually being tampered with is probably a lot less.
That's right. Yeah. So that reduces our risk of theft is by burying it.
I was working on a site in Alberta there, and somebody came. We're way out in the country. Somebody came and cut all of our grounded wires right at the base. Like, so you couldn't even tap onto them or anything. We had to like dig it all off. It was great.
For the buried grounds. Oh my god.
I think it was my boss. He just wanted to extend the job.
Oh, yikes. Anyway, so that's buried. So it sounds like we're leaning toward Rincy. It sounds like we're leaning toward solar, battery, maximum DC voltage coming off the panels. I don't know, but I think probably 24 volts. But I saw look at a couple alternatives, right? 240 volt AC out. Our total storage start with maybe 200-300 amp hours, but you just add more batteries, right? And add more panels. Make everything expandable. buried cable for distribution. How do we want to do distribution? Like, we can't run a cable to every house. I don't know how that works. Like, you run one main one and then you put like junctions underground, or
probably it's better to do a ring main.
Ring main, okay.
I can draw.
I don't know like about mains power distribution. I don't know how those networks, what the topology is like.
So basically, solar system is a power source. Yeah.
Yeah.
We go in. Let's say clockwise. Number 12 will be our power. Yeah.
Yeah.
Solar system. Number 1, house 1. Number 2, house 2.
Okay.
And so on. You know.
Okay, so you could cut it. So you could cut it anywhere to work on it, and everything will still stay energized.
Yes. Yes.
Okay, that makes sense.
And let's say every house should have a small board with a
right
circuit breaker. But,
okay, so this is our solar power plant up there. These are the house panels, and this is the panel at the house, right?
No. This is the red square on the top. This is your solar installation. Solar panels plus inverter plus batteries.
Yes.
So we're going to go more of a centralized type setup instead of each individual house.
From that, 230 going to the house number 1.
Yeah.
Yes.
Yes.
Going to the house number 2, 3, and so on. Right.
Yeah.
Then you daisy chain off.
On the house number 1, you're going out.
Just a parallel at each house.
To the cable to the consumer unit.
Well, and this can be like we can do it like substations, right? It depends on the physical geometry of the town, what the like optimal geometry is, right? But we do want to have this ring structure at least, correct?
Yeah.
We use less cable if we use a ring structure.
Yeah, and it's more reliable. Okay, that's how that works. I was thinking of like a star network, right? I don't know. That's just where my mind goes, but this makes a lot more sense to me now. Okay, so this is your little house here, and the house looks something like that. Right. Okay, so that sounds like the topology that we're going with. Yeah, we're just kind of figuring it out on the fly, right? Like my heart's not set on anything, so this sounds fine to me. And you know, the nice thing about this is that it's also when someone someday comes along with power poles over here, right? You just do this, right?
Yeah.
Then that's
You get additional
so that's
like
that satisfies our grid integratability requirement. We don't have to design it to push power this way. We don't care about that.
No.
We just want the option. And then it's kind of a backup too. We just want this possibility, which is easy enough to do. Okay, so it sounds like we're leaning toward ring topology, AC power distribution, and not doing it like a hack job, not just wiring in one little light bulb in every house. Put in a main breaker panel in every house. Do it like a real electrician would do it, not like a farmer would do it. Like do a real job, something that's actually safe, just like in your house at home. Like go look at your panel. You don't have to re-engineer the electrical panel. Just do it like that. So that's how we'll do it.
When we connect voltage in series like this, isn't there a voltage drop across every house? So you mean to say the last house in the ring gets nothing?
Sorry, there's another cable. there's
it's in parallel, and then it daisy chains to each house.
So this is like, live. Oh, I made a capital L, live.
In the case of ring topology, we have smaller voltage drop because basically we double cross-section area of the cable by putting it on the ring. So
yeah, and then to actually take it off to the house, you do that, right? And then this house over here, I'm not sure. I'm kind of speculating. You guys are the experts. I'm not. And then to take it off this house, you just do the same
thing. I don't understand it. What you do now, because what the second black lines to?
Well, like I'm not an electrician, right?
So the easiest way to think about it, it's just like when you go, say, like in a shop or a garage, how you have 8 lights, right?
Yeah.
So it's got one power source. That's your first initial ring there. And what you're doing is just paralleling off that power source to each house. So it's just right off the ring, and then you tie in parallel, and that's going to feed a house.
Yeah.
It's just,
that's
just
what
like
I want to do. It has to be in parallel, right? How can it be in series?
No, it won't. So each junction box where he has the blue box, that's parallel to the house. So you got your main ring, and then you parallel power to the house, and that's so you have one source and then parallel, so that way you can disconnect each house with its own little breaker.
So like this is the ring coming by the house, right? We have like live and neutral, or since it's 240, I don't know how it works. I don't know how it works. Whatever. Voltage 1 and voltage 2 coming by on the ring. Here's the panel for the house. And here's a light bulb, right? So then, there's actually 2 wires going to the light bulb. I want that in black. Right. So this is like that. Through the panel, through like obviously a breaker, a main breaker, and then a breaker for this circuit. You guys kind of get the idea, right? So that's like what we do, right? And then this ring, this goes in a circle, so that you can, like, it's connected to the solar plant on both ends, so you can just do that.
This is exactly the same as you wiring a street lamp posts.
Yeah, street lamps. Yeah, that's like if one goes out, they don't all go out. Yeah, well, whatever. Anyway. Okay, so it sounds like we're set on... I don't hear any strong objections. Just to reiterate for the 5th time, solar power, probably 24 volt DC going into the charge controller and battery bank. So that means 2 12 volt batteries in series, and then you can have a bunch in parallel. 240 volt AC mains distribution system, direct burial cable, ring topology, or whatever, based on the geography of the town, the real geography, whatever topology works best. It might be a ring with several branches, like substation branches. Main panel installed in every house, just like a regular old electrical infrastructure in North America or in any developed part of the world. And the grid integratability component, it sounds like we're going to go with a yes on that, but it won't be up. It will only be down, and it will only be like a retrofit option. That was another thing I saw on Amazon. Stupid enough as it is, they sell like automatic solar switchover relays. They're pretty cheap actually. So it's something that I could put in my house, you know. So it's something that we can do here too, but we don't have to do that.
Yeah, I listed on the sources. That's kind of what I did. The integratable or not. I mean, either to tie into the grid or potential, like we spoke last time of how far do we want to give these people, like expansion of capabilities.
I mean, why do half a job, right? That was my initial thought for the whole project. I was like, just go all the way, right? Just hook them up for power, and then all you have to do is bring a pole in. Simple. And the solar is just kind of a stopgap thing for now. So, okay. Any other ideas, comments? That was a big deciding the topology and kind of getting everyone on board with the details was a big one. So I think I'm happy to end it there. Anyone else have anything else?
We also should have RCD and a circuit breaker in the board, or RCBO instead.
Sorry, remind me, what is the difference? What is an RCB?
Oh,
it's like a GFCI.
This is combined RCD and a circuit breaker together.
Oh, we call it a GFCI, right?
Sorry, could you repeat, please?
I think we call it a ground fault circuit interrupter.
Ground fault circuit.
I think it means the same thing as an RCB, but I'm not exactly sure.
It does, yeah.
Okay.
Yeah.
And there's like
Australia and working Canada, yeah.
Okay. Residual current device. It's called.
Yeah. It's the same thing. And there's two options for that. There's either local, like, in your bathroom, or you can put them in the panel too, but they're just really expensive. Anyway.
They cost about in case of RCBO, this is a circuit breaker and a leakage protection together, so it's about £20 it's costing.
Oh, okay, if you buy them wholesale, I guess it's cheaper.
Schneider Electric is the best for basically.
Oh, I'm sure someone would disagree with you about that.
Go with Federal Pioneer, you're good to go.
Yeah. I don't know. Makes no difference. It's like John Deere and Case IH. Those are tractor companies, by the way, if you guys don't know. All right, let's shut her down there. I'm happy with our progress. So the first person I'm going to start bugging is Dino, who is unfortunately not here. But you guys can continue working on your parts by yourselves, and I will only start bugging you when the time comes. So, see you guys later. Have a good weekend.
Yes.